All right, here is our first in the series of solutions to the example problems given in the projectile packet. All right, and this particular problem, it's a max height problem. We're looking for the max height. We have an initial velocity of v naught equals 40 meters per second at an angle of 40 degrees above the horizontal. So we're just looking for the max height. This is a straightforward max height problem. Okay, as always, we are going to take our velocity vector, and we'll just pretend that's 40 degrees, and break it down into our vertical and our horizontal components. All right, this is what we usually do. Here's V naught and here's theta. But of course, what's kind of strange in this one is, as in most max height problems, is we're not really dealing with anything that's going on in the x direction. Usually we solve for time and then bridge across with that. But in this particular max height problem, everything that we're going to deal with is strictly in the y direction, right? Here's V naught y, and that's because it's just max height. We're not asking how far it's going. Like, you could have a problem where it says when it achieves its max height here, right, what position down range has it gone? But that's not what we're doing in this problem. It's just straightforward max height problem. So all we need to do is worry about what's going on in the y direction. So let's get straight what we have going on here. We have g is our acceleration as always. Our delta y is, we're looking for delta y max. Okay, that's important because we have a specific thing that goes with that. And remember that this is, whoops, that was a mistake. We have a special case here, and that is that when we have a max height problem, when we have a max height problem, we know that V naught is 0 at maximum height. So with that goes this, okay? So those go together, and so our delta y max right here is, we don't know, and our V naught, we know, is going to be V naught sine theta. Okay, that's this component right here of our initial V naught. Okay, so now we have what? We have four things. We have 1, 2, 3, 4 items, 3 of which we know, and 1 of which is an unknown. So with acceleration, delta, V naught, and V apparent, then we know that we will be using the timeless equation, right? Conspicuously absent, we'll be using the eternal equation. So we know that Vy squared is equal to V naught y squared minus 2g delta y, okay? Notice that we have the y subscript in here indicating that all the things we're talking about are in the y direction, and we have the very specific y acceleration, which is negative g, okay? So I'm going to get that out of there so it's not in the way. All right, so now what we're going to do is we have our special case here where Vy we know is 0 when we are at delta y max, okay? So now we still have V naught y, but V naught y is V naught sine theta. We're going to square that minus 2g delta y. All right, now just rearranging algebraically, remember, rearrange letters, not numbers. We're going to say that delta y max is equal to V naught sine theta squared over 2g. Okay, if you want to do more steps than that for the algebra, that's fine. If you want to have some interceding steps, that's perfectly okay. And now that we have it rearranged, we can go ahead and plug in the numbers. And the numbers that we have indicate delta y max is going to be equal to 40 meters per second times the sine of 40 degrees. We're going to square that. We're going to divide by 2 times 9.8 meters per second squared. Notice what we have here. We have units with all of our numbers. Numbers in units. This is dimensionless. Numbers in units. We have just a plain old 2 here. So now if we look carefully and we do a quick unit analysis, we have meters squared over seconds squared divided by meters per second squared is going to leave us with meters. And that's what we would want for a displacement. All right, now we're going to go and plug in all of our numbers, and once we calculate everything, we end up with delta y max is equal to 33.7 meters. So this says that if we fire a projectile in the air at 40 meters per second, that's like right here, like this, that because of its upward velocity, it will go up in the air as it moves forward, of course, a total height of 33.7 meters as it moves forward. Then it'll start to descend and then come down. We don't know what happens over here. We just know that where that will happen. All right, so that's example problem number 1.